Okay, let's give you guys some more practice. Determine if this integral converges or if it diverges. So press pause and have a go. Okay, so to do this, we should be comparing this to e to the power of minus x. So we should be comparing this to e to the power of minus x. So if you look at this, just looking at this only, let's just look at x plus 1 over x. So if you draw this graph, it will look something like this. When x is big, it wants to do a straight. When x is big, it wants to do a straight line. When x is negatively big, it wants to do this. When x is small, well, let's draw a reciprocal. Hang on. When x is small, it wants to do the reciprocal graph. So now joining the two, it will look something like this. Now, if you look at this, so we are looking at this versus this. So we are looking at this. Hang on, we are looking at this versus this only. So if you look at y equals x, it will look something like this. It will look slightly less. It will look slightly less. So beyond one, this thing here is always going to be positive. Beyond one, this thing here is always going to be positive. So you're always going to add a tiny amount extra. So here you've got x plus another tiny amount extra, meaning that this thing here will always be bigger or equal to this thing here. Because here, beyond 1, this thing here will always be positive. It will be an extra amount, a positive amount. So when you add a positive amount, this thing here will always be bigger or equal to this thing here. So hang on. So looking at this thing here will always be bigger or equal to this thing here. So now you've got a negative here. So let's just imagine this as being 1 over e to the so we are just removing the negative. Now imagine this as being 1 over e to the well, if this bubble here is bigger than this bubble here, then overall this thing here will be less than this thing here. So we can actually say that this whole thing here will be less than or equal to this thing here. Think about it. And we've already seen that many times in the past that this thing here converges. So from 1 to infinity, this thing here, this area here will converge. Well, if this thing here converges and it's always bigger or equal to this thing here, then this being smaller, it will have no choice but to also to converge. So therefore this whole thing here will converge. Okay, so the whole thing here will converge. So next one. So establish if this thing here converges or if it diverges. Remember, it's from 0 to 1. It's from 0 to 1. Okay, so press pause and have a go. Okay, so to do this, we should be comparing this to 1 over the square root of x. So we should be comparing it to 1 over the square root of x. So if you look at sine, the absolute value is sine of x. Well, sine of x looks like this. Well, the absolute value will be something like this, something like that. But so the absolute value is in between 0 and 1. So this bit here is in between 0 and 1 because sine graph looks like this. Maximum is 1, minimum is negative, but the absolute value here will look something like this. So this bit here will always range from 0 to 1, 0 to 1. So if the highest value that this thing here could be is 1, then we can say that this thing here will be less than or equal. So this thing here will be greater or equal to this thing here, because the highest value that this thing here could be is 1. So let's make it the maximum value here, 1. So this thing here will be greater or equal to this. Now we've seen many times in the past, hang on, 1 over x, this region here would diverge. If you have a square root of x, it will look something like this. This thing here will converge. We've seen many times. It should be ingrained in your mind by now. From 0 to 1 of this thing here will converge. Well, if this thing here converge, it being greater than this thing here, then this thing here must also converge in the region of 0 to 1. So this thing here will converge. Okay.